Here we're going to have a very quick look at HotShot, and in particular we'll see how to create and run a flow. We'll make a synthetic trace and deconvolve it, and then list the two traces side by side. And we'll make bitmaps of the two traces spectrums. Then we'll read some shots. And join their traces together so as to form one long trace from each shot. And along the way we'll see how errors are trapped and highlighted. Well, now there are several menu items, and each one has its own help topic. But this is the one we're after. All the routines are listed here. Flows are held in text files, and here I've created a new one via the menu. We can type into the box directly or use a text editor via the editor button, either the built-in editor or an external one that you specify. We use call equals keywords to invoke the various routines. The routine that makes a synthetic trace is called make, and the one that lists a trace is called list1. Well, now, in these flows, blanks have no significance except as separators, so we could just as well have typed this. An exclamation mark in column 1 will turn any line into a comment line, and anything between chevrons is ignored. Let's check the flow and see what we get. Well, that was a bit too quick to see, but check has in fact checked two flows, the one we gave it and one that it made itself. It's this one that's got all the keywords listed with all their values, either the default values or the ones we typed. We can ignore this stuff, it's just information about the input or the output. We'll go back to the Flow tab. If we toggle the Show Defaults button, what we see is that generated flow. All the defaulted values are now chevroned. We'll make a synthetic 4-sample trace. We can chase across to help and find makes documentation. And we see that we need to define the samples via a keyword trace equals. So let's do that. We'll give our trace sample values of +12, +4, -5, -2. And check it. Incidentally, the Show Defaults and the Hide Defaults buttons point to different files. We can check either one, but we mustn't forget that they are different files. Let's run the flow. So now HotShot's skipped across the monitor tab and we can see that the job's finished. The run tab shows us our trace list. So back to the flow. We'll just get rid of these comment lines. Now when make creates a trace, it writes it to an area of memory. We can give that area a name if we wish. And similarly, whenever list1 gets a trace, that trace comes from memory. And we can say from where if we want to. In HotShot's flows, these areas of memory only hold one trace and its corresponding header at a time. Let's just check it. Now input and input 1 are the same thing, and so are output and output 1. Some routines have more than one input or output port, as we'll see shortly, and that's why we need indices. Let's surround our 4 sample wavelet with zeros, 25 at each end. The various list number formats are described in another video. So let's check it. And run it. And here's our little wavelet surrounded by zeros. We'll add a call to decon. And give its output a name. We'll change list1 to the 2 trace version, list2, and tell it the names of its 2 inputs. And see what we get. So here are our 2 traces. And we see that the output's nearly a spike. And so it should be, because our 4 sample wavelet is minimum phase, and that's routine decon's default assumption. We'll go back and make some spectrums of our 2 wavelets. We can look at the flows flowchart. And look at the 2 bitmaps. So decon's white on the amplitude spectrum, but the two phase spectrums assume that the wavelet's reference time is 0 seconds. So we'll change that and the time series scales. We'll have a quick look at the run file to find the wavelet's reference time. And here it is, 100 milliseconds. So we'll change our flow and see what we get. So we fixed the phase spectrum's reference times and used better scales for the time series. Now we'll see how errors are trapped and highlighted. This little flow reads some shots and AGCs and bitmaps them. So let's make a few errors and see what happens when we check the flow. So it highlighted all the errors it found during check loop 1, but what about the ones it can't highlight? Errors of omission. AGC, for example, has a keyword tgate equals, and this keyword doesn't have a valid default. So let's see what happens. So it caught the error in check loop 2, the one where it checks the generated flow with all those keywords listed. We'll correct that tgate error and run the flow. The only errors that can escape the checker are data dependent, that's to say runtime errors. So let's make one. There's a routine called append_n that for each record joins all the traces together so as to form one long trace. We have to code maxfold large enough. If we look here, we can see that we need to code a minimum of 48. And that's how runtime errors are caught. So we'll correct the error. And see that we end up with one very long trace for each shot. Almost 6 minutes long. And that's it for this quick introduction to HotShot's flows.